Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is mean and standard deviation in binomial distribution. In this video, we are going to examine the mean, variance and standard deviation of the binomial distribution. Okay, let us start with the formulas and we can also learn what does this mean. The formulas. Okay. Mean of a binomial distribution. So what would be the formula for that one? Mean is denoted by mu. It is either denoted by mu of x or just mu, which is equal to n times p. The mean of a binomial distribution with parameters n. N is the number of trials. And p. P is nothing but the probability of success for each of the trial. This can also be denoted by small m, because we generally denote mean by m. No issues even if you use the small alphabet m. Mean means one measure of the central tendency, either of a probability distribution or of the random variable. It is characterized by that distribution, in which distribution it comes under. Hope you got an idea on mean. Okay, now let us see variance. Variance and standard deviation are closely related. Am I right? Standard deviation is nothing but square root of the variance. So whatever expression given under the radical is considered as variance. Does this make sense to you? Variance is denoted by s square. Standard deviation is denoted by either s or sigma. Okay, now let us see the formula for variance. Variance means a measure of how far a set of numbers is spread out. So that is the meaning for variance. Variance is either denoted by s square or sigma square. So in binomial distribution, variance formula is n times p times 1 minus p. 1 minus p is nothing but q, or the number of failures. The variance of a binomial distribution is s square, which is equal to the parameter n. N means the number of trials. N times p. P is success. 1 minus p means failure. Does this make sense to you? Okay, now let us move on to the standard deviation. Standard deviation helps us to show how much variation or dispersion exists from the average, that is the mean or the expected value. So this is what standard deviation denotes. Okay, let us see the formula. As I already told you, standard deviation is nothing but square root of the variance. So just include square root in the variance formula. N times p times q, or n times p times 1 minus p. So this is the formula for mean, variance and standard deviation in binomial distribution. As with most probability distributions, examining the different properties of binomial distributions is important to truly understand the implications of them, because if you learn something, you should know how to imply them in your real life. Am I right? The mean, variance and standard deviations are the three of the most useful and very informative properties that has to be explored. Okay, the easiest way to understand the mean, variance and standard deviation of a binomial distribution is just to use that in your real life. Okay, let me give you a few real life examples too. Very popular example in probability is tossing a coin. So I'm going to consider a coin tossing experiment, in which you toss the coin 12 times and recorded the number of heads. So number of getting a head is the success here. So in this example, if you performed this experiment over and over again, what would the mean number of heads be? So on average, you would expect half the coin tosses to come up heads. Am I right? Because if you toss a coin, you get chances of getting a head 50% and getting a tail is 50%. Am I right? So therefore, the mean number of heads would be 6 in general, because if you are tossing it 12 times, getting a head on average is 6. In general, the mean of the binomial distribution with parameters n, number of trials, and p, the probability of success for each trial. So you should look at the question carefully and identify what are all the given information. In this question, the number of trials n is given and the success p is also given. So what would be the mean? You can easily apply the formula that we learned just before. So mean is nothing but n times p. What is n here? And p. Success is 1 out of total two possible outcomes. So 12 times half is 6. So this is how we find the mean from any binomial distribution question. Now let us find the variance of the binomial distribution. Variance is denoted by the coin is tossed 12 times. So n is equal to 12. A coin has a probability of half or 1 out of 2 of coming up heads. Therefore, P is 1 out of 2 is 1 over 2 is 0.5. And it is enough if you just identify P. Once you get familiarized with this concept, you need not mention 1 minus P. Instead 1 minus P, you can directly use Q, because Q denotes the failure, the remaining leftover. Okay. So 12 times half, half times half, this will give you 3. So now how will you find the standard deviation? Are you going to apply the same formula again? No need. You can just take the square root of the variance that you got. So when you're asked to find mean, variance and standard deviation, you have to follow the same order. First find the mean, and then variance, and then standard deviation. You can also replace NP by 6 because you have already found the mean, no? So in case if it is confusing you, you just leave it. You just use the formula, identify the given information, plug in all the information and do the calculation. This is how you can easily get the answer. Okay, let us find the standard deviation now. That's it for this example. Flipping coin experiment or the great way to understand the properties of binomial distribution. Hope you're clear with this example. Mean, standard deviation and variance are the basic properties. You should also make yourself familiarized with the additional properties of the binomial distribution, which are the median, mode and covariance of the binomial distribution. We can discuss those additional properties in a separate video with suitable examples. Okay, I'm going to take one more real life example for mean, standard deviation and variance here. First, we discuss the tossing coin, flipping coin experiment. Now we are going to do one example with rolling die. Okay, please read the question and identify what is N and P. Here, find the mean, standard deviation and variance for the number of threes that appear when rolling 30 dice. So totally you are going to do 30 trials. Am I right? So N would be 30. And what would be the success variance for the number of threes that appear? So on a die there are 6 sides. One of the 6 sides will have number 3 or 3 dots on it. So getting success is 1 out of 6 sides. Am I right? So P is 1 over 6. So what would be 1 minus Q? Here I am going to denote 1 minus P as Q. Now finding mean, standard deviation and variance is easy. All you have to do is write the formula, substitute the values taken from the question and do the algebraic calculation. So mean would be, formula is NP, just plug in 30 and 1 over 6. If you multiply, you'll be getting 5. If you're going to use Q, it will be very easy for you to memorize the formula. So variance would be N times P times Q. I'm giving the answer in decimals. So if you are using decimals in your answer, you should round the answer with 4 decimals, 4 digits after the decimal point. Okay, now standard deviation. Standard deviation is just the square root of variance you got. So you need not again write the formula, plug in everything and take the square root. It is just enough if you take the square root of the answer you got for the variance. I'm getting 2.0412. Hope you're clear with this example. Okay, when you're dealing with mean, variance and standard deviation in binomial distribution, you may get one more question. You'll be asked to find whether the experiment is usual or unusual. So let's see that too. Now let's see about identifying unusual results in probabilities. If under a given assumption, for example, such as assumption that a coin is fair, the probability of a particular observed event, such as no more than one head in 10 tosses in a coin, is extremely small, right? So we conclude that the assumption is probably not correct. Okay, using probabilities to determine when results are unusual. Let's see that. There are 2 types. One is unusually high and another one is unusually low. If the number of successes, for example, X be the number of successes in N trials, X successes among N trials is an unusually high number of successes if probability of X or more is less than or equal to 0.05. Same way the other one, the number of successes, X successes among N trials is unusually low number of successes if probability of X or fewer is less than or equal to 0.05. So from this you can identify whether the results is unusually high or unusually low. First you have to identify unusual results and then you have to check whether it is high or low. Okay, let me give you the range rule of thumb. According to range rule of thumb, the most values should lie within 2 standard deviations of the mean. So we can therefore identify unusual values by determining if they lie outside these limits. So maximum usual value will lie in mu plus 2 pi, 2 sigma. Minimum usual value will lie in mu minus 2 sigma. If I give you an example, you will understand this concept. Here is an example. Is it unusual to roll 30 dice and get exactly 8 threes? So please recall an unusual value. Unusual value is greater or less than 2 standard deviations from the mean. Right? So I'm going to use mu plus 2 sigma here and check. This is the continuation of the previous example. Let me add that that question too. So for this question we got mean as 5. This is the variance and standard deviation we got for this problem. I'm going to use the same thing, mu and sigma here. Sigma means standard deviation. So replace mu by 5 and sigma by 2.0412. This calculation gives me 9.0824. This is greater than 8, no? We are not getting exactly 8 threes. So this is not unusual. That's it for this example. Hope you got an idea on the important properties of binomial distribution, mean, variance and standard deviation. In case if you get any query regarding this video, kindly let me know. See you in the next video. Have